Hello dear students, welcome to Tejami YouTube channel. In this video I am going to give list of formulae as well as some important points which are very required for KCET and NEET examinations. Okay, so I'll be explaining all the points quickly, so take a notebook and write down the topics that I am explaining here. Okay, so first of all, we represent an element by using this like X, A and Z. Okay, give an example, that is 1H1. This is the hydrogen. See here, this is represented by Z, this symbol is represented by X, and 1 is represented by A. What is the Z, X and A? Dear students, you have already learned this. I'm just giving the revision kind of thing here. So here Z is number of protons and A represents, it is the number of protons plus neutrons, or it is also called, what is that, atomic mass. And X represents the symbol, which element is that. Okay, if it is lithium we write Li, if it is boron we write B, if it is antimony it is Sb, like that. Arsenic As, like that. Okay, next, what are fundamental particles? See, electrons, quarks, neutrino, positron, antineutrino, these are called fundamental particles, but in PUC we don't have much theory about these particles. Okay, so we mainly study, what is this, the protons, neutrons and electrons. Actually electrons are what is that, fundamental particles, but protons and neutrons are not fundamental particles. Okay, do remember that. Next we have an atom. So if you consider an atom, it consists of protons, neutrons and electrons. Protons and neutrons are present inside the nucleus. Okay, so protons and neutrons will be present inside the nucleus. So protons and neutrons are together called nucleons. Do remember that. So you may call protons or neutrons as nucleons. Okay, or sometimes you call them as hadrons and baryons. Okay, so do remember this one, it is very important. Like nucleon means it may be proton or neutron, like that. And electrons will be revolving in different shells. So you can calculate the number of electrons in each state by using this formula 2n square. Okay, in the first state n value is 1, second state n value is 2, third state n value is 3, like that. And they will be revolving around the nucleus of an atom in different shells, whose angular momentum is given by nh by 2 pi, and energy is given by, like, we have already calculated that in the atoms chapter, right? Make use of that. Then here, what is the mass of proton, neutron and electron? See, mass of proton is given here 1.67 into 10 to the power minus 27 kg. This is not the exact value. Actually you will get 1.67 to something you will get. For neutron it is 1.674. so mass of neutron is slightly greater than mass of proton, but they are almost equal. Mass of proton and mass of neutron are almost same, so I have given the value here 1.67. so in AMU, see, look at this, here you can see the difference. For proton it is 1.0073 AMU, and for neutron it is 1.0087 AMU. Okay, now next, for electron, mass of the electron is given by 9.1 into 10 to the power minus 31 kg. These are all very important topics and data that you need to know. Next, I think you have studied 1 AMU also. Define 1 AMU. 1 AMU is the mass of carbon 12 nucleus divided by 12. Okay, so if I had taken theory class, I would have explained why exactly is this and what exactly you will get from this and all, but as of now I'm just giving the formula. Okay, then 1 AMU value is 1.66 or 1.67 into 10 to the power minus 27 kg. See, look at this, mass of proton 1.67, mass of neutron 1.67, and 1 AMU 1.66 or 1.67, almost same values, 10 to the power minus 27, 10 to the power minus 27, 10 to the power minus 27. Okay, so do remember that all those values are almost similar. Okay, next, rest mass energy. This is given by Einstein. E is equal to mc square, where we consider mass is a form of energy, and from that we can calculate what is that, different things, like if mass is given you can calculate energy. So I think in 2020 NEET question paper they have given calculate the mass equivalent to 1 AMU. And here also into 1992 also it was asked, energy equivalent to 1 AMU is how much? Like that you can calculate energy. Say energy equivalent to 1 AMU is 931 mega electron volt. Even if they give 1 gram also you can calculate. Even if they give 10 gram also you can calculate by using the formula E is equal to mc square. Very important formula. Okay, so this is very important. E is equal to mc square, and that is equal to 931, especially for 1 AMU, energy equivalent to 1 AMU. Next, dear students, we have the different properties of nucleus. So size of the nucleus or nuclear size. Look at this. If you consider the nucleus and it consists of proton, if there is only one proton, so or one neutron, the size of the nucleus is this much. What if we consider two protons and one neutrons, or let me consider them as nucleons. It may be proton or neutron. So 4 nucleons are there, 5 nucleons are there, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what is happening here? A value is increasing. If A value increases, size of the nucleus also increases, means volume of the nucleus also increases. That's why volume of the nucleus is directly proportional to A, means mass number. It may be number of protons or neutrons inside it. Okay, so if V is directly proportional to A, since the volume of the sphere is 4 by 3 pi r cube, it is volume of the nucleus is considered as volume of the sphere, because nucleus is in spherical shape like this. Okay, so 4 by 3 pi r cube, 4 3 pi r constants, so I can directly write r cube. What is that? R cube is directly proportional to A, and you can take this cube this side, you will get r is directly proportional to A power 1 by 3. Then if you remove this proportionality sign, you will get a constant called r naught. Its value is 1.2 into 10 to the power minus 15 meters. Here I have written Fermi femtometer. Fermi or femtometer is given by 10 to the power minus, how much is that? 15 meters. Okay, so this is very important formula, most important formula. Do remember this, where r naught value is given. How much is that? 1.2 into 10 to the power minus 15 meters are just for me. Okay, then I have given few graphs here. How does the r value vary with A, and volume of the nucleus vary with A, and radius of the nucleus vary with A power 1 by 3. Here r is directly proportional to A power 1 by 3, V is directly proportional to A. That's why we are getting linear graph here. And for this one, r is directly proportional to r with A, you get like this. Now we'll move on to next one. It is nuclear density. How do you calculate density? The density is calculated by using the formula mass by volume. Here mass of the nucleus is given by A into m. How? See, if the nucleus consists of only one nucleon, mass is m, 2 nucleons 2m, 3 nucleus 3m, 4 nucleons 4m. So number of nucleons is represented by A, number of protons plus neutrons, into mass of each nucleon. So A into m divided by volume is 4 by 3 pi r cube. So we know what is r cube. So substitute the value of r cube here. You will get 4 by 3 as it is. R cube is written as r naught power 3 into A. Correct? So r naught power 3 into A. We can substitute the value of r cube. R naught to the cube into A. How? Because r is r naught power 1 by 3. If it cube it, take cube, this 3 will cancel out, you will get A. So in place of r cube, I have written this. Okay, na? Next, this is very important. So here what happens? A will cancel out, where r naught is constant, m is constant, 1 by 4 by 3 is constant, pi is also constant. So you will get a constant value. To remember, means density of any nucleus is independent of number of nucleus present. it is always constant. If even if you take hydrogen or helium, lithium, beryllium, boron, uranium, so the density of the nucleus will be constant. May vary practically, but almost constant. Do remember that. Based on that also you may expect questions. Like they will give different values for density and ask you to check whether it is correct or not. Okay, no, density will be constant. Next, nuclear force. You have already studied Coulomb's force, you have studied gravitational force, but now you are learning nuclear force. This is the force which is holding the nucleus together inside the nucleus. So let me consider here. Proton is there, neutron, proton, neutron, proton, neutron, proton, neutron. P, N, P, N, P, N, P, N, like this. Okay, the force between these two or these two or these two or these two or these two that holds the nucleus together inside the nucleus is what matters. Okay, here that is nuclear force, and here I have given the different properties of nuclear force. Nuclear force is the strong force or strongest force in nature. Okay, and there is weak nuclear force also, of course. It is repulsive force. Next, non-central, attractive, especially the strong nuclear force is attractive and weak nuclear force is repulsive. Do remember that. Charge independent. So here you can see, even though the neutron is not having the charge, it is getting attracted to a proton. So neutron is neutral, zero charge, proton is positive charge, still there is a force between them, that is called charge independent. It is not dependent on charge, whether the charge is there or not, this acts. Next, short ranged. This is this force acts only inside the nucleus, and size of the nucleus is very less, like it is of the order of 10 to the power minus 15 meters. So that's why it is very short ranged. Does not follow inverse square law, like force directly proportional to 1 by r square or inversely proportional r square. This you can see in Coulomb's law. F is equal to k q1 q2 by r square, or in what is it, Newton's law, F is equal to g m1 m2 by r square. Like that is not there, so it is not a inverse square law. Okay, next, saturation in nature means it is getting satisfied. Okay, so it is, I mean, the force will not increase or decrease normally. Okay, it is getting only some quantity of force acted on other particles, and it is not going to increase more than that. Next, mediates by mesons. This is not that important, but here spin dependent, this property is very important. Okay, these are all very important points. Do remember, dear students, and do understand the concept properly. Okay, next, how does the potential energy of nucleus vary with the distance? As like if I consider the distance between two nucleons inside the nucleus, okay, they are having some potential energy. So if the distance decreases, what happens? So potential energy increases negatively, and if the distance increases, again potential energy is increasing in this manner. But at this particular point, potential energy is negatively maximum. Okay, do remember that. Or you can consider the lowest value. Okay, negative slope left side and positive slope right side. Okay, so this side you can see the repulsive force left side, and this side you can see the strong nuclear force of attraction. Okay, so that is how it varies. If the distance between the nucleons vary, if they come closer they get repelled, if they go far away they get attracted. That is how the nucleus holds the nucleons together inside the nucleus. Next, we have the strong nuclear force. Do remember that it is always attractive force, and weak nuclear force, it is repulsive force. Okay, next, nature of nuclear force. Okay, so nuclear force is what is that, always attractive, especially because it is not mentioned. Nuclear force, which nuclear force is this? In nuclear force there are two forces. One is strong nuclear force, and second one is weak nuclear force. So since it is not mentioned, we consider it is strong nuclear force. That's why it is attractive. This was the question asked in the previous years. Weak nuclear force specifically dimension, so it is repulsive force. Then one more question was asked in KCET as well as NEET, so very important. So force between proton, force between neutron, force between proton. Since it is independent, what it is? Nuclear force is independent of charge. The force between all the nucleons will be same. Okay, here like this. Next, mass defect. So this concept also you have studied. So this is very important formula. Delta M is equal to ZMP plus NMN minus M. Okay, so you must have already studied how we get this particular formula. I have been telling you that if you want to understand this formula, list of formulae, you must have studied the theory concept properly, understand the concept well from your teachers. Okay, you just ask them how did we get this formula and all, so that you can understand this formula easily. Or if in case if you want to learn this concept in detail, please do let me know in text box, or you can comment me in the video so that I will explain this later. So then you get this graph also. How does the binding energy per nucleon vary with A value? First it is increases and then decreases. Very important concept. Based on this also they have asked one CET question previously. Okay, so binding energy per nucleon vary with A. How? It varies like this. First increases then decreases. Okay na, do remember that. Next we have Q value of reaction. Here we have Ma minus Mb into C square. So what is the formula here? It is Q is equal to binding energy of products minus binding energy of reactants, or you can use this also, but here the mass should be in mega or that AMU. Okay, atomic mass unit. So this formula is very important. Q value of the nuclear reaction, binding energy of products minus binding energy of reactants. Okay, there will be some change in mass of the reactant particles, so that you need to get, then you have to subtract it by 931 mega electron volt or C square. Okay, the average binding energy of a nucleon inside the atomic nucleus is 8 mega electron volt. Binding energy of a nucleon inside the any nucleus it may be, so it is average, it is 8 mega electron volt. Do remember this value, and there are some few values like this that I will explain here. Next comes radioactivity. In that see, after nuclear decay, what is that, like heavy elements get nuclear fusion or fission reactions. So after that, especially not fusion, it is fission, so they get radioactive materials, they get into radioactivity because of their instability, further instability. Next, after that they undergo alpha decay, beta decay and gamma decay. First of all, what is alpha particle? See, doubly ionized helium particle is called alpha particle. Okay, most of the student doesn't know what is alpha particle. It is, see, this represents number of protons, this represents number of protons and neutrons, this represents the charge. Yes or no? So the right side one is charge. Usually we represent it by minus or plus. Charge is represented like this in the element, but initially I told you, so like this, right? This is, for this we don't write plus or minus, we just write A, or you can write that A here also, so that A is this, Z is this. Okay, for helium Z value is 2, A value is 4. Next, beta decay. Electrons or positrons are called beta particles. See here there are two types, beta plus and beta minus. Okay, next, gamma decay. Gamma means it is electromagnetic radiation. Photons of high energy are emitted. So this is a particle, this is also particle, but this is the radiation. Okay na? Next, electron capture. What is electron capture? Here proton combines with electron, becomes neutron and releases neutrino. This is called electron capture. Electron capture, very important. Then the law of radioactivity. The radioactivity law is defined like this, or stated like this. The rate of decay is directly proportional to the number of active elements present inside the nucleus, or active present nucleons. Okay, so rate of decay is directly proportional to n. Why? Because if there are nucleons, there is activity. If there is no nucleons, how do you expect this? Okay, so there is this That's why there is this. Okay, do remember that. So minus will come this side, and you'll get a constant also lambda, that is called decay constant. Very important, because based on this you may expect different questions also. So if they give in terms of mass, you have to write this: m is equal to m naught e power minus lambda t. If they give in terms of activity, you will get like this: a is equal to a naught e power minus lambda t. Like this, they may get different formulae. Do remember them. Then half-life. What is half-life? The time after which number of nucleons become half of its initial number of nucleons is called half-life, and I have given the formula for that here. That is T off is equal to 2.303 log 2 divided by lambda, that is equal to 0.693 divided by lambda. Next, Q value in decay. Okay, how do you calculate Q value in alpha decay? I have already given you the formula for that. Here there is one more formula that I am going to give. So here this is the element, radioactive element, which is undergoing decay. What decay is that? Alpha decay. Alpha means there will be emission of 2He4 plus 2. Okay, plus 2. So here this is the parent nucleus, and these are the what is that, daughter nuclei. Okay, so here the energy is released during this reaction. So in terms of kinetic energy of alpha particle, so this alpha particle will be having some energy, and this will be having some kinetic energy. That is given by kinetic energy is equal to momentum square divided by 2m. You have already studied half m square, right? Half m square, just multiply by m, divide by m, you get this formula. Okay, so p square by 2m, and then if they ask you to calculate ratio of alpha particle and the product nucleus, so we'll get like this. This is very important formula, so especially for NEET. Okay, Q is equal to Ke alpha plus Ke y. So this kind of question based on this formula, in KCET there were no questions asked, but it's very important formula. Next we have nuclear fusion. Here what happens? Two or more lighter nuclei like hydrogen combine together to become heavier nucleus like helium and all. 1H2 1H2 you can consider. 1H2 1H2 becomes helium 2He4 with the release of some energy, or you can consider some other examples also, and they release some energy. So this reaction is called nuclear fusion reaction. So this happens especially at higher temperature, and the product produced here are not harmful, and it is uncontrolled chain reaction. We can't control this reaction especially, so nuclear reaction, but it is safe compared to nuclear fission. Okay, here Q value released per nuclear reaction is 20 mega electron volt. Sometimes we write 18 mega electron volt also. So this is this here. Next, I have given few points which are very important. Note on them. Radius of the nucleus is around 10 to the power minus 15 meters to 10 to the power minus 14 meters. Then in case of that formula, R is equal to R naught a power 1 by lambda 1 by 3, right? So here R naught value, proportionality constant, is 1.2 for me. Then density is given. So then gravitational force, electrostatic force and nuclear force are in the ratio 1 is to 10 to the power 36 is to 10 to the power 38. So here nuclear force is the strongest force. Do remember that. Next, packing factor, it is given by delta m divided by A, change in mass or binding energy. What is that? Mass defect divided by A. This is mass defect divided by A. Next, radioactivity, that we have already written. Okay, so these values are very important, the SI unit and different units for activity. So becquerel, it is 1 decay per second. Curie is also a unit of radioactivity, but SI unit, especially if they ask, it is becquerel. Okay, Curie is 3.7 into 10 to the power 10 disintegration per second, and Rutherford, it is 10 to the power 6 disintegration per second. Next, half-life. Half-life is 2 log log 2 to the base e, and that is divided by lambda, that is equal to 0.693 divided by lambda, and mean life is given by 1 by lambda, that is equal to t half divided by 0.693, because t half is equal to 0.693 divided by lambda, right? If you substitute the value of lambda here, you will get this. If you substitute the value of lambda, you will get this. Next, alpha decay. X is equal, the reactant or the radioactive element that decays into this products, okay, then that reaction is given like this. And beta decay, I told you, like electron gets accelerated, electron gets released, so there you get this reaction. And then gamma decay. So I already told you, during gamma decay, means gamma decay is nothing but it emits the photons of high energy. Gamma radiations you have studied, right, in electromagnetic waves. Those radiations get emitted. So number of gamma rays is equal to number of alpha rays plus number of beta rays. So that happens. This you need to remember. Then nuclear fission reaction. Here I have just given the formula, like how the heavy nucleus bombarded with neutron get excited. This is excited nucleus, and then it gets released into, or it gets converted into other decayed into other particles, lighter particles, and get stabilized, during which it releases neutrons, 3 or 4 neutrons also. So next we have isotopes, isobars, and isotones. These concepts are very important that you have studied for board. Okay, so isotones means Z value is same, isobars A value is same, isotones N value is same. Okay, then this formula is very important. Most of the questions, most of the times they have asked a question on this formula. That is, here in this case the formula is given by number of power emitted by photons. Number of atoms undergoing fission is N, energy released is E, and per given time. Okay, so what is the power released from the reaction? Usually we use this one, like what is the power of the photon, where the number of photons are getting emitted per second is this much, and the energy of each photon is h nu, that is given. Okay, do remember this formula in terms of power and energy of the key. Make use of this formula. Then neutron reproduction factor, rate of production of neutrons divided by rate of loss of neutrons. This you study in nuclear reactors concept. Okay, for your juniors it is going to get deleted. Okay, so next, neutron decay. Neutron decay is given like this. Neutron gets decayed into proton, electron, and an anti-neutrino. Tumba important idu, very important, anti-neutrino. Next, proton decay. Proton decays into neutron, electron, and a neutrino. This is very important. Then fraction of nuclei undecayed. Okay, so that is given by this. So this based on this they have asked one question, n divided by naught, fraction of nuclei undecayed. So next, n is equal to t by t naught also you can use. Okay, so these are the list of formulae and some of the concepts that you need to remember for competitive examinations, board examinations also, dear students. So I hope this content is going to help you for your examinations, for the examinations. Okay, so take note of all these things, and then solve the questions from different previous year question papers. My best suggestion is, if you want to crack any examination and if you want to know about any competitive exam, you will have to solve the previous year questions, so that you will get an idea which particular topic I have to study a lot. Okay, so not during the examination, it is from the day one when you join the college. It's very important. From there itself you have to start studying for competitive examinations, and you have to solve more and more questions, especially previous year questions and NCERT questions. Okay, so all the best. If you like the video, please subscribe and share it to your friends. We'll meet you in the next video. Till then, take care. Bye bye.